Welcome to my YouTube channel. Today we'll discuss about the number system and the properties. Natural numbers or the counting numbers starting from 1 and continuing infinitely. These numbers we use in our daily life to count things. 1 is a natural number, 5 is a natural number, and 100 is a natural number. Integer numbers include natural numbers and the negatives of the natural number and 0. Both sides of positive and negative, like from 0 you can go to up to positive side 1 2 3 and negative side -1 -2. Definitely a 0 is an integer, minus 10 is an integer, minus 10 is a negative value of positive integer 10, and 7 is also an integer. Rational numbers are numbers that can be expressed as the quotient or fraction of integers, where the denominator is not 0. 1q, where p and q are integer numbers. 3 over 4 is a rational number. 5 over 2 is a rational number. 0.25 is a rational number because it can be expressed as 1 over 4. Rational numbers are those numbers that cannot be expressed as a simple fraction. They cannot be written as a ratio of two integers. Radical 2 is an irrational number. Pi is an irrational number. Real number is an irrational number which is equal to 2.712828. Real numbers. Real numbers comprise both rational and irrational numbers. They encompass all numbers that can be represented on the number line and include numbers such as a fraction, decimal, integer, and irrational numbers like pi or radical 2. Examples are 0 is a real number, 3 or 4 is a real number, and radical 2 is a real number. Axioms of additions. For all a comma b belong to real number, then a plus b belong to real number. Like we have 2 plus 2 and 3 belong to real number, then 2 plus 3 is equal to 5, which will also belong to a real number. An associative property. For all a, b and c belong to real number, then in bracket a plus b plus c is equal to a plus bracket in bracket b plus c. So this property will be satisfied. Commutativity. If for all a comma b belong to real number, then a plus b which will be equal to b plus a. Then comes identity. So there exists an element. So this sign shows that there exists an identity element 0 such that for all a belong to real number, a may be any real number, then a plus 0 which is identity will always equal to a, or we can say that a number will not be affected by the addition of the identity. So inverse. For all a belong to real number, there exists an additive inverse such that a plus negative a will be equal to 0. Means for every real number there exists its inverse which makes its value 0 after adding it to it. Axioms of subtraction. 3 axioms can be inherited from the axioms of additions. Identity. There exists an identity element 0 such that for all real numbers a minus 0 will always equal to 0. Means it will not affect the value of a, any real number. So the 0 will not affect the value of a real number. It's called identity. So inverse. For all real number, there exists a subtractive inverse a such that a minus a will be 0. After subtracting the value a from a will be equal to 0, and that will be called subtractive inverse. Axioms of multiplication. So first comes kilo here. For all a comma b belong to real number, then a dot b, if we multiply both numbers, that will also belong to a real numbers. Associative. For all a, b and c belong to real number, then a in bracket a dot b dot c is equal to a dot in bracket b dot c. So these values always will be equal. Commutative is same. If for like the addition, for all a comma b belong to real number, then a dot b will be equal to b dot a. Identity, there exists an identity element 1 such that for all real number a dot is equal to 1 or 1 dot a is equal to a. For all real numbers excluding 0, there exists a multiplicative inverse such that a dot a inverse is equal to 1 or a inverse dot a is equal to 1. This is all about the lecture. If you have any question, you can comment, and we will continue from here in the next video. So please like the video and subscribe the channel MathicByte.